All right, we're going to continue in lesson 6.1. We're talking about scatter plots, correlation, and fitted lines. All right, it says estimate the correlation coefficient of a linear fit. Remember, a linear equation is an equation of a line, okay? So we're looking at a correlation coefficient denoted by R. And when you look in your calculator, you're going to see R. And anytime we're talking about correlation coefficient in your assignments, it will be denoted by R as well. Well, where R is between -1 and 1 is a statistic that describes how closely the points in a scatter plot cluster about a line. A strong positive correlation has a correlation coefficient close to 1. And a strong negative correlation has a coefficient close to -1. If there is no apparent correlation, R is close to 0. All right, it says use the information from task 2 and 3 to answer the questions. Look again at the graphs from task 3. Okay, so these are loosely related. These are closely related. These are loose. And these are close to the line. Okay, so it says match each graph with the best description of its correlation coefficient R. All right, so this one has a strong correlation. So that means it's going to be closely related to +1. So graph 2. So graph 2 and R is close to 1. All right, graph 4 is close to the line, but it's negative. It's going downhill. So graph 4 is close to -1. And then this one's positive, but it's just somewhere between 0 and 1. So graph 1 is between 0 and 1 because it is positive. And then graph 3 is negative, but it's not very close. So it's just somewhere between 0 and -1. All right, look again at the table in task 2. All right, so the data in task 2 says, which number is the best estimate for the correlation coefficient R? That describes the hot chocolate. All right, remember when we looked at the graph of the hot chocolate, these lines are closely related for a negative correlation. So it would be close to -1, which -0.97 is close to -1. That just indicates that there is a strong negative correlation there. All right, it says, what advice would you give someone selling hot cocoa? People will buy more hot cocoa when the air temperature is hot. That's not true. People will buy more hot cocoa when the air temperature is cold. The air temperature does not affect how much cocoa people buy. So people will buy more cocoa when the temperature is cold. All right, it says what variables can you think of that might have a correlation coefficient of about -1? So that's something that you can think about. We're going to move on to task 5. If you have any questions, let me know. All right, lesson 6.1, task 5. Distinguish between correlation and causation. A common error when interpreting bivariate data is to observe a correlation and conclude that a causation has been demonstrated. Causation is when a change in one variable causes a change in the other variable. If there is causation, it is reasonable to expect correlation between the variables. However, a strong correlation does not imply causation. Both variables may instead be influenced by a variable not included in the data set, or the causation may be the reverse of what was assumed. Below are the descriptions of 3 studies. Use the given information to complete parts A through G. All right, the results of a study about the age of children and their respective heights are given. The height of a child and the age of that child have a strong positive correlation. So that makes sense. As the kid gets older, they get taller. All right, so it says based on the correlation noted, the height of a child increases as his or her age increases. The correlation is due to causation. Okay, so in this case, correlation and causation go hand in hand. As a child gets older, they should get taller, up until a certain point. All right, then it says the results of a study about students' absences and students' grades are given. The number of absences a student has and that student's grade point average has a strong negative correlation. All right, that makes sense to me. If students are not in school, then their grades are going to go down. So that makes sense. All right, so it says based on the correlation noted, grade point averages decrease as the number of absences increase. The correlation is due to causation. All right, so again, in that case, those two are related. All right, it says the results of a study about the number of people jogging and the number of people biking outdoors are given. The number of people jogging and the number of people biking outdoors have a strong positive correlation. ENS says, based on the correlation noted, the number of joggers increase as the number of bikers increase. The correlation is not due to causation. So just because people are biking does not mean people are running. Now, the fact that it might be a weekend may mean that both there are more runners and bikers that day because they're out of work, but it doesn't have anything to do with bikers means there's more runners. All right, it says explain how another variable could have a causation relationship with each of the original two variables. All right, so again, whether it's a holiday or the day of the week, or maybe it's a weekend, that could cause there to be more people out exercising, but biking doesn't cause people to go run. All right, that's all for task 5. All right, lesson 6.1, task 6. This is our final task. So it says fit a linear function to data. When there is a strong correlation between two variables, you can use a line of fit to construct a linear model for the data. To estimate a line of fit, position a straight edge through the middle of the plotted data points so that the data points are evenly dispersed about above and below the line. Use the straight edge to draw a line. Then select 2 points on the line to write the equation. All right, so you can see they've drawn a line through the points here. So it says the scatter plot for the data of hot cocoa sales from task 2 is shown. Draw a line of fit and write an equation for the line of fit. All right, so to write an equation, you're going to select 2 points and find the slope. Remember, slope is rise over run, or your difference of y's over your difference of x's. Now, the 2 points you choose, it doesn't matter. You can choose any 2 points from this set of data. It's good to choose points that fall on an intersection here on the graph because you know those are exact points. But if you remember, there was a table of values in task 2 that you could use those exact points from there as well. All right, so it says select 2 points on the line. So they used 30 and 300 and 60 and 160, and it says find the slope. So they did 160 minus 300 divided by 60 over 30, and we got negative 14/3 for our slope. So they're going to use point slope form to write an equation. So you're going to take one of the points, they're using 30 and 300 to plug in for x and y, 30 and 300, and then plug in slope for m. And then they just rewrite it and solve for y, which puts it in slope-intercept form. All right, it says, how do you know what points to select? All right, so you can select any points you want, but let's see what it says. Select the highest data point and the lowest. Select the leftmost and the rightmost. It can be any 2 points on the line as long as they're not too close together. Okay, so it can be any 2 points. All right, it says select the appropriate numbers to complete the sentence. The slope represents the average decrease of, so it's negative 14 over 3, so it's a decrease of 14 cups of cocoa for an increase every 3 degrees in Fahrenheit. All right, it says fill in the blank with the number that completes the sentence. The y-intercept represents the 440 cups of cocoa that would be sold when the temperature is, all right, remember, y-intercept is always 0 and whatever the y is. So your y-intercept is going to have 440 cups of cocoa when the temperature is 0 degrees Fahrenheit. So that's when it would hit 0. All right, if you have any questions, please let me know.